All right, welcome back to another Math Workouts with Coach Payne and Lesson 6, What is Slope? And so I want to remind us, right, calculus is the mathematical study of continuous change, and slope is going to play a key role in calculus because not only do we need to understand slope, what is this rate of change, what is this average rate of change, how does this difference quotient play an important role and this instantaneous rate of change in calculus? So in our algebra days, we used the slope to help us graph a line quicker than plotting points. And we defined it that the slope measured the steepness of a line. Okay. All right, so let's see how we're able to kind of pick that up. So I'm going to do this. Okay, so getting into our elementary days in algebra, we had said that the slope was going to be the rise over the run. However, this limited our deeper understanding of what slope really meant. And so what we want to illustrate is that this numerator is going to represent here delta y, which indicates that it's going to be the change in the y values. And that had to deal with the independent. I misspoke. It had to deal with the dependent quantity, and the run, delta x, was dealing with the change in the x values that dealt with the independent quantity that we talked about last time. And so now we're going to want to give this a little bit more structure. And so you could see here, right, delta y is the change in the y coordinates, delta x is the change in the x coordinates. However, you want to start referring to the dependent quantity versus the independent quantity. And so there were several different values of slope. We could have our positive slope, we could have our negative slope, we could have a zero slope, and we can have an undefined slope. That's what we talked about in an algebra course. And so now when we get into this concept of rate of change, right? Rate of change, remember calculus is the mathematical study of continuous change. Well, guess what? Slope is a calculus concept because here it says the rate of change, aka the slope, deals with one quantity, right, of y with respect to one quantity x is the rate of change y to the change of x. And so that slope is denoted as a fraction. And what we're talking about here is we're talking about the change in y per one unit in x. And so remember that linear growth that we were talking about previously, dealing with the example of the population in Flagstaff, and we talked about that the number of residents was increasing by 1,000 people per year. This is an example of a rate of change. And if we would write that rate of change is m would equal 1,000 over 1, where this represented the population, and therefore this represented the time, right, in years. And you see how it says the change in y. So the change is 1,000 per, that one unit is 1 year, per year. And so we talked about that when you're dealing with a model of linear growth, remember that each unit of time you're increasing by a constant. Well, guess what? Not all functions are linear. And we saw that when we were taking a look here at this antler weight, right, in kilograms versus age in years. So what if we wanted to find the rate of change? Well, in this particular case, this is not a linear model. And so therefore, if a function has a non-linear growth, we are going to discuss this average rate of change. Average rate of change, again, this is going to represent slope, we could think about. However, we're going to have to use an interval by using 2 points on the function. And so what that would illustrate, so maybe here at, let's say at this point here, to, they say this point here, I'm going to struggle, but you're able to, that's not the greatest, you're able to create a line, right, that intersects the curve at 2 distinctive points. And so what we would discuss here is that that represents the secant line when you connect 2 points on the function on some closed interval. And that is what we are going to focus on in calculus, is that the average rate of change is going to equal the slope of a secant line. And how we go about finding that average rate of change is we're going to have to use a mathematical formula, right? And so in this particular case, what we're talking about here as the average rate of change would focus on, well, what is our y-coordinates? Our y-coordinates here represented the antler's weight in kilograms. So this is going to illustrate here that if we were focusing on the average rate of change, we would focus on the change in the antler weight in kilograms. All over here, the change, and we're focusing on here on age. Age in years, HT. And so when we're talking about the average rate of change, then your units for this particular case would be kilograms per year. And so what we would do if we were interested in finding that average rate of change, and this is what we'll talk about, is that we would need to use the data point here, and then this was at 10, and then we would use the data point here to find that average rate of change, which would be an increase over the closed interval. So that closed interval from B2 to 10. And what this would illustrate is these y values would be increasing at some particular rate over that interval. And that is where the slope information comes from. And so what's going to happen is once we, talk about the average rate of change, there's a little bit more in depth here that we are going to talk about by utilizing the slope formula. And again, the average rate of change is going to discuss how fast a function is changing with respect to something else changing. And then this difference quotient is going to play an important role in calculus, because this is going to allow us to formalize the average rate of change here, as you could see, by utilizing a more detailed function. And then we're going to take that average rate of change and then talk about the instantaneous rate of change. And so let me just highlight this, that this is key in calculus, that there is a big difference between the secant line, which connects 2 points on a curve using the endpoints on some interval. However, the tangent line touches the curve at a single point. And there's going to be a big difference, is that the average rate of change finds the slope over an interval, whereas the instantaneous rates of change finds the slope at a particular point. And this is going to be key on our calculus journey. All right, so again, once we get into calculus, how are we going to find this instantaneous rate? Well, that is going to use our derivative rules. And that is what we're going to spend part of the course. Remember, calculus is evaluating limits, being able to compute derivatives, as well as integration. And we're going to summarize that over the 15 weeks here.